Good morning, students. Today we are going to discuss the conic section. It is an important topic of a class 11th mathematics. In this section, we study different shapes, that is a circle, parabola, hyperbola, ellipse. You know about the circle. In junior classes, you studied about the circle. That is, a circle is a locus of a point whose distance of a fixed point is always constant. But here the different view, here the different aspect in which you see the circle, the definition of circle. Okay, so let us start. Conic section are the conics or the curves that are obtained by the intersecting a plane with double napped rectangular right circular cone. Circle, ellipse, parabola and hyperbola are the example of the conic section. What is a double napped cone, right circular cone? A double napped cone can be obtained by rotating a line, let us say M, about a fixed vertical line, let us L. You have to rotate a line M with respect to another fixed line L. Here you can see in the diagram the line M is rotated around the fixed line L, then the shape generated is double napped right circular cone. Here upper napped and the lower napped. L is the axis and M is the generator because it generates the double napped right circular cone. Here the fixed line is called the axis of the cone and M is called generator of the cone. The intersection V of L and M is called the vertex of the cone. The intersection of L and M is called the vertex of a cone. Different conics formed by the intersecting a plane and a double napped cone. It depends on the angle between the plane and the axis of the cone and the angle between the generator and the axis of the cone. Here you can see the axis angle between the generator and the axis of the cone is theta 1. If theta 1 is the angle between the axis and the generator and theta is 2 is the angle between the plane and the axis, then for the different values of theta 1 and theta 2 we get different conics which are described with the help of a table. Can you see the table? If the theta 2, which is the angle between plane and the axis, is equal to 90 degree, it is only one napped cone is entirely cut by the plane. If the only one napped is entirely cut by the plane and the angle between plane and axis is equal to 90 degree, in this case conic form, that is a shape formed, is circle. Only one napped, that is the upper nap, in this case upper nap, you can cut lower nap also, is cut by a plane such that the angle between plane and the axis, that is theta 2, is equal to 90 degree, so the shape formed is circle. Okay, second case, if theta 2 is greater than theta 1 but less than 90 degree, if theta 2 is equal to 90 degree, then in this case circle formed. If theta 2 is less than 90 degree but greater than theta 1, theta 1 is the angle between generator and axis and theta 2 is the angle between plane and axis. If the angle between plane and axis is less than 90 degree but greater than the angle between generator and axis, in this case the shape formed is an ellipse. Okay, Here theta 2 is less than 90 but greater than theta 1. So the shape formed is an ellipse. It is also in the one napped, it may be lower or upper. The third case is if theta 1 and theta 2 both angles are equal and only one nap of the cone is entirely cut by plane. In this case, the shape form is a parabola. Here you can see that if the angle theta 1 and theta 2 both are equal in one nap, then shape cut by a plane is a parabola. Okay. Last case is if theta 2 is greater than 0 degree but less than theta 1. In this case, both the naps of the cone are entirely cut by a plane, a shape, a conic is formed, a hyperbola. Here, the theta 2, which is the angle between plane and axis, is greater than 0 degree but less than the angle between generator and axis, the hyperbola, and hyperbola is formed. Plane is entirely cut by the two naps, and here theta 2 is a small angle but greater than 0 degree but less than theta 1. The shape is a hyperbola. Now degenerated conics. The conics obtained by cutting a plane with a double napped cone at its vertex are known as the degenerating conic. The vertex is the point where generator and axis are intersecting each other. If theta 1 is the angle between the axis and the generator and theta 2 is the angle between the plane and axis, then for different values of theta 1 and theta 2 we get different conics which are as shown below. If theta 2 is equal to 90 degree, now the plane cut at the vertex, not in a half of the nap, that is a one nap and the second nap, it is cut by the vertex. In this case, first is if theta is equal to 90 degree, then the shape formed is a point. If theta 1 and theta 2 are equal, then in this case a straight line is formed. When theta 1 equal to theta 2 and plane cut in a one nap, then a parabola is formed. But when it is cut by the vertex and theta 1 equal to theta 2, a straight line is formed. And if theta 2 is greater than or equal to 0 degree but less than theta 1, a hyperbola is formed. It is also case in the two naps, but theta 1 is not equal to 0 but it is greater than 0. Okay. Now the first shape, which is circle. You know the definition of circle? A circle is the set of all points in a plane that are equidistant from a fixed point in the plane. The fixed point is called center of the circle and the fixed distance from the circle is called the radius of circle. This equation of a circle, first equation when the center h comma k and the radius r is given. In this case, the equation of the circle is x minus h whole square plus y minus k whole square is equal to r square. The equation of a circle when center is origin, that is the value of h comma k is 0 0 and the radius is r, is on putting the value h and k 0 0 we get x square plus y square is equal to r square. The first example is that find the equation of a circle whose center is minus 5 comma 3 and the radius is 6. So value of h is minus 5, the value of k is 3 and the radius is equal to 6 on the putting the value in equation x minus h whole square plus y minus k k square is equal to r square, we get the equation of circle, that is x square plus y square plus 10x minus 6y is equal to 2. The second shape is parabola. A parabola is set of all points in a plane that are equidistant from a fixed line and a fixed point, not on the line in the plane. Fixed point not lie on the fixed line. Okay, fixed point fixed line पे नहीं होना चाहिए. Parabola is the set of all points in the plane which are equidistant from a fixed point and the fixed line. The fixed line is called the directrix of parabola. The fixed point is called the focus of the parabola. The line through the focus and perpendicular to the directrix is called the axis of the parabola. The line which passes through the focus and perpendicular to the directrix is called the axis of the parabola. The point of intersection of parabola with the axis is called vertex of the parabola, and the line segment that is a perpendicular to the axis of parabola and passes through the focus is called the latus rectum, and the condition is that whose endpoint lies on the parabola. With the help of a diagram you can clear all these points. Fixed point is focus, fixed line is directrix. The line which is perpendicular to directrix and passes through the focus is the axis of the focus. Parabola intersect the axis at which point is called the vertex. Here O is the vertex, origin is the vertex, and the line which is perpendicular to the axis and passes through the focus and endpoints lie on the parabola is called latus rectum. Here the four cases of parabola. The first case is y square is equal to 4x, open towards right side. The standard equation is y square is equal to 4ax, where a is positive. The coordinates of focus a comma 0. The coordinate of vertex is 0 comma 0. Distance between vertex to focus and distance between vertex to directrix is equal. So if the distance between vertex to focus is a, so distance between vertex to directrix is also a, but in the negative direction is minus a. So the equation of the directrix is x is equal to minus a. The length of the latus rectum in the case of a parabola is equal to 4a. So the coordinate of this point is a comma 2a, and for this a comma minus 2a. Focus is the midpoint of this line. Axis of the parabola is x-axis, and the equation of x-axis is y is equal to 0. So axis of parabola is y is equal to 0. Second case, open towards left. The general equation is y square is equal to minus 4ax. Now the coordinates of focus is minus a comma 0. Vertex is at origin, that is 0 comma 0. Equation of directrix minus a, so then here the distance x is equal to a. Again the length of latus rectum is 4a, and the axis of parabola is x-axis. Then the equation of axis is y is equal to 0. Third case, open towards upward. In this case, the standard equation is x square is equal to 4ay, where a is positive. Now the coordinates of focus, because focus lies on the y-axis, is 0 comma a. Coordinate of vertex again at origin, that is 0 comma 0. Now the directrix is parallel to x-axis, so the equation of directrix is y is equal to minus a, and the length of the lattice rectum is 4a. Through diagram all things are clear. Now the axis of parabola is y-axis, so equation of axis is x is equal to 0. Focus 0 comma a, directrix y is equal to minus a, which is parallel to x-axis. Length of latus rectum is 4a. The equation of parabola x square is equal to 4ay. Now the last case is open downwards. Equation is x square is equal to minus 4ay. Coordinate of focus is 0 comma minus a. Coordinate of equation of directed is equal to y is equal to a. Vertex x origin, that is 0 comma 0. Length of latus rectum is 4a, and the axis of parabola is y-axis, so its equation is x is equal to 0. For example, consider a parabola x square is equal to minus 16y. On comparing with the general equation, that is x square is equal to minus 4ay, we get 4a is equal to 16, a is equal to 4. It is the parabola which is open downwards. So the coordinate of vertex at origin 0 comma 0. The coordinate of focus is 0 comma minus a, so is 0 comma minus 4. Equation of directrix y is equal to a, so the equation of directrix is y is equal to 4. Length of latus rectum is 4a, so 4 into 4 is equal to 16 units. And equation of axis, y-axis is the equation of the parabola, so equation of axis is y is equal to 0. Now the degenerated parabola. If a fixed point lie on the fixed line. Now if the fixed point lie on the fixed line. अभी मैंने आपसे पहले बोला था कि फिक्स पॉइंट उस फिक्स लाइन पे नहीं होना चाहिए. But if the fixed point lie on the fixed line, then the set of all points in the plane that are equidistant from the fixed point and the fixed line is a straight line, which is our previous case. If a plane cut through the vertex and theta 1 is equal to theta 2, then we get a straight line. It is a degenerated case of a parabola. Okay. Now next is ellipse. An ellipse is a set of all points in a plane, the sum of whose distance from fixed to point in the plane is constant. Ellipse is a set of all points whose sum of distance to fixed point is always constant. These two fixed points are called the foci of the ellipse. The constant, which is the sum of the distance of a point on the ellipse from the two fixed points, is always greater than the distance between two fixed points. The distance between two fixed points is always less than, or you can say that the constant, that is a distance, the sum of the distance of a point from a two fixed point is always greater than distance between two fixed point. The midpoint of the line segment joining the foci is called the center of ellipse. The line segment through foci of the ellipse is called the major axis, and the line segment through the center and which is perpendicular to major axis is called the minor axis. The end points of major axis are called the vertices of ellipse. The eccentricity of the ellipse is the ratio of the distance from the center of the ellipse to the one foci to one of the vertices of the ellipse. सेंटर से फोकाई के डिस्टेंस अपॉन सेंटर से वर्टेक्स के डिस्टेंस का रेशियो क्या होता है? इसेंट्रिसिटी. An ellipse is symmetric with respect to both coordinate axes, that is ellipse x axis and y axis दोनों के along symmetry होता है. The line segment that is a perpendicular to the major axis of the ellipse and passes through the focus of the ellipse and the end coordinates of these line are lie on the ellipse is called the latus rectum. जैसा कि पैराबोला में आपने अभी देखा था, a line which is a perpendicular to the axis of parabola and passes through the focus, and the end coordinates are available on the parabola. Same here, the line which is perpendicular to the focus, is perpendicular to the axis of the ellipse, and passes through the focus, and the end coordinates present on the ellipse is called the lattice rectum of ellipse. Now we can discuss all above points in diagram also. Here the two fixed points are foci. You can consider a point P whose sum of distance, two fixed point, that is PF1 plus PF2, is always greater than distance between two fixed point. It is our first point. Okay, the midpoint of two fixed point is the center of vertex. Line which passes through the two fixed point is called major axis. The line which is perpendicular to major axis is called minor axis. Ellipse where cut the major axis is the vertex of ellipse. The ratio of distance center to fixed point, one fixed point, to center to one vertex is called the eccentricity of ellipse. Okay, now there are two cases. First case, standard equation of ellipse is x square upon a square plus y square upon b square is equal to 1, where a is greater than b. Center is 0 comma 0, vertex is a comma 0, and second vertex is minus a comma 0, so you can say that plus minus a comma 0. Endpoints of minor axis 0 comma b and 0 comma minus b. Foci, that the two fixed points are c comma 0 and minus c comma 0. Here the value of c is ae. So there are two foci, ae comma 0, and second is minus ae comma 0. The length of the major axis, that is a and a, is total 2a along x-axis. The length of minor axis b and b, that is total 2b along y-axis. Distance between two foci, that is c and c, is 2c. The value of c is ae, so distance between two foci is 2ae. Relation between a, b and c, the relation is a square is equal to b square plus c square. Length of lattice rectum, the line which is perpendicular to major axis and passes through the focus, and the end coordinate present on the ellipse. The length of the lattice rectum is 2b square upon a. In the case of ellipse, the value of eccentricity is less than 1 and is equal to c upon a. It is the ratio of a distance between center to one foci to the center to vertex. Okay. Second case, standard equation is x square upon b square plus y square upon a square, where a is greater than b. In this case, the ellipse major axis along y-axis and the minor is along x-axis. Center is at 0 comma 0. Now the vertex are 0 comma a and 0 comma minus a, because along the y-axis vertex is present, and points of minor axis along x-axis is plus minus b comma 0. Now the length of the major axis is 2a, but it is along y-axis. Length of minor axis is 2b along x-axis. Length of foci along y-axis. Again, the relation between ABC is a square is equal to b square plus c square. C is equal to AE. Don't forget, C is equal to AE, where E is the eccentricity of ellipse, which is less than 1. The length of the latus rectum is 2b square upon A, and the value of eccentricity is C upon A. But in this case, the general equation is x square upon b square plus y square upon a square is equal to 1. For example, consider an ellipse 9x square plus 4y square is equal to 36. On dividing by 36 both side, we get x square upon 4 plus y square upon 9 is equal to 1. It is the second case, that is x square upon b square plus y square upon a square is equal to 1. The value of b square is 4, so value of b is 4. Similarly, a square is equal to 9, so a is equal to 3. You know the relation a square is equal to b square plus c square. We get the value of c, that is under root 5. The value of eccentricity is c upon a, that is root 5 upon 3. The coordinate of the center is 0 comma 0. The coordinate of the vertex is 0 comma plus minus a in this case. The coordinate of the foci is 0 comma plus minus c, and the length of the major axis is 2a along y axis, and the length of the minor axis is 2b along x axis. Okay, now the next shape is hyperbola. A hyperbola is a set of all points in a plane, the difference of whose distance from two fixed point is always constant. In the case of an ellipse, the distance between the sum of the distance from two fixed point is always constant, but here the difference of a point from a two fixed point is always constant. Okay, the difference of a the difference of whose distance from two fixed point is always constant. The two fixed point are called the foci of hyperbola. The constant, which is the difference between a point on the hyperbola from the two fixed point, is always less than. Here the difference is less than between distance between the two fixed point, that is the distance between the foci of hyperbola. The midpoint of the line segment joining the foci is called the center of the hyperbola, same as a ellipse. The line through the foci is called the transverse axis. It is not the major axis, it calls the transverse axis. And the line which is perpendicular to the transverse axis is called the conjugate axis. The point at which hyperbola intersect the transverse axis is called the vertex of hyperbola. The eccentricity of the hyperbola is the ratio of a distance from the center of the hyperbola to one of the foci and to one of the vertex of the hyperbola. सेंटर से फोकाई के एंड सेंटर से वर्टेक्स के डिस्टेंस के रेशियो को आप क्या कहते हैं, एसेंट्रिसिटी. In the case of the hyperbola, the value of eccentricity is greater than 1. A hyperbola is symmetric with respect to both coordinates, same as an ellipse. The line segment that is a perpendicular to the transverse axis and passes through the focus and the end coordinates of these lines available on the hyperbola is called the latus rectum of hyperbola. Now here two cases arise in the case of a hyperbola. The equation of hyperbola, the first case is x square upon a square minus y square upon b square is equal to 1. In this case, center is 0 comma 0. Vertex are plus minus a comma 0. These are the vertex. Foci plus minus c comma 0. Again Here the C is equal to A by E. Conjugate axis. Now the conjugate axis is y axis and the transverse axis is x axis. The length of the conjugate axis is 2b and the length of transverse axis is 2a. Distance between the foci is 2c. Now here the relation is c square is equal to a square plus b square. In ellipse, this relation is a square is equal to b square plus c square. Length of the lattice rectum is 2b square upon a and the eccentricity which is greater than 1 is c upon a. Second case, y square upon a square minus x square upon b square is equal to 1. Only transverse axis and conjugate axis are interchangeable, that is, now the transverse axis along y axis and the conjugate axis along x axis. Center is 0 comma 0, vertex is 0 comma plus minus a, foci is 0 comma plus minus c, conjugate along x axis, transverse along y axis. So the length of the conjugate is 2b and the length of the transverse is 2a. Length between the foci is 2c. Relation between ABC, again c square is equal to a square plus b square. Length of the lattice rectum is 2b square upon a and eccentricity greater than 1, which is c upon a. The question is that consider the hyperbola 16x square minus 9y square is equal to 144. On dividing by 144 we get x square upon 9 minus y square upon 16 is equal to 1. On comparing with the general equation we get the value of a is equal to 3 and the value of b is equal to 4. It is the second case. So c square is equal to a square plus b square. We get the value of c. The value of eccentricity is c upon a, that is the 5 upon 3. Coordinates of the center 0 comma 0. Coordinates of the vertex is plus minus a comma 0, that is plus minus 3 comma 0. Coordinates of a foci plus minus c comma 0, that is plus minus 5 comma 0. Length of the transverse axis is 2a. Length of the conjugate axis is 2b. Distance between foci, that is 2c. Length of lattice rectum is equal to 2b square upon a. Okay. Next point is a hyperbola having equal length of both axes, that is the transverse axis and conjugate axis are the equal length. It means 2a is equal to 2b, that is 2a is equal to b is called an equilateral hyperbola. It is an important question for your exam. When the length of a transverse axis and the conjugate axis are equal, then the hyperbola known as the equilateral hyperbola. Thank you, class.